project proposal, and then ngayon din tayo mag-group. So, you are 45 students enrolled in this section 3203. So, be using random team generator para ma-generate kung sino yung magka-group. So, for this section, I'll be having six groups. Siguro yung iba may 8, yung iba 7. So, at the end of meron tayong format na for the design project, meron tayo for research proposal. I mean, design project proposal. So, for this design project proposal, nakalagay din sa pinakadulo yung statement on the contribution of each team member. Sa proposal pa lang meron ng ganun. So, same with the final paper for design project. So you have to include, and then that page will be signed by each of the member of the group just to see kung pepermahan ba nila na makita na yun ba yung talagang naging contribution mo. So to start, let's start with the random team generator. So ito naman is sa ibang section. Ilalagay ko dito yung section, yan, ipipaste ko lang dito. Tama, no? Ito. So, 45 students, yan. I will generate 6 groups, then run natin. So, dalawang, ayun. Ito na ba nga kayo? So, may members, may 7 members. So, ayun. So, for group 1, screenshot ko din naman to. So, for group 1, we have Kyle, Ken, Junel, Junella, Zerdan, John, Christian, Jury. So, group 2, so we have Rick Van, Jericho, Isa, Justin, Adrian, Kisha, Emmanuel, King Russell. For group 3, we have Aram, Rose, Michaela, Mark, John, Alma, Brizel, Saijal. For group 4, we have Christine, Ian, Aldrich, Rainiel, Aaron, Lourdes, Julian. For group 5, we have Vince, Kurt, Ivy, Rain, Ralph, Kay. Anong basa dito? Ayari? Tama ba? Tama ba? Pagkakabikas ko, Ayari Lancel. Pakinig ba ako?
Yes po, ma'am.
Okay. And then for the last group, we have Carlos, Eric, Daniel, Justin, Mark, Neil, Christine, Aliyah, Maxine. Okay? So, screenshot ko na lang ito. Wait lang. And then, share ko sa ating GC. Wait lang, hindi ko makita yung GC. And then, wait. Okay, so again, ito na yung magiging final group for your design project. Okay, so for the research proposal, for proposal ng design project proposal at yung mismong final project, meron tayong magkahiwalay or magkaiba na format. So ito yung format for the design project. And then, ayan, wait lang. Download ko ba to? So ito yung, download ko lang. So ito yung magiging format ninyo for your design project. Meron ba kayong tanong sa groupings? Any question?
Wala naman po.
Okay, so before I discuss, upload ko muna para maano na siya. Okay, wait lang. Ay, mali. Hindi. Okay, wait. Mali. Ano ba yan? Wait lang. Sa isang section ko lang siya na-post. Sa O6 lang. Okay, wait lang. So, para visible na din to sa inyo, ano ko na siya. Ay, O6 na pala yun. Okay. Okay. So, yan. Meron tayong rough proposal or the design project proposal template. I will also attach na then doon sa Google Classroom yung design project template naman with the rubrics for presentation and for the final manuscript. Upload ko lang din para hindi na tayo paano ba upload? Yan. Format design project. Design project format. Bakit wala? Okay, so yun, na-post ko na to dun sa Google Classroom. So kung gusto nyong balikan, buksan nyo na lang sa Google Classroom. So for the format, so magkaiba yung format natin ng proposal and then dun sa final project na So itong format na to is for the format na ng design project. Format and content ng design project. So, kompleto na siya dito. Okay? So, guided naman kayo. And then, meron din kayo dito guide questions after nyong matapos. So, sample calculations, proofreading and checking. Ayan. And then, checklist for the final report. So, after nyong matapos yung inyong design project manuscript or final report, then you can answer the following questions. Kung kompleto ba yung laman ng inyong proposal. Okay? So, nandito na din yung rubrics natin for the design rubrics and then for presentation rubrics. So, 60% will be coming from the design project manuscript, and then the 40% will be coming from the presentation. So, yan, you have to make sure na makasagot kayo doon sa presentation, at maayos yung pag-present nyo. Okay, kasi 40% of your grade from your design project will be based from your performance. Especially, yung 60% naman is for the manuscript. But before we focus on this design project format, syempre, kailangan meron kayong syempre meron kayo dapat topic. So this is yung proposed design project proposal. So ito ay proposal pa lang. Titingnan natin kung i-approve siya or hindi. So submission of this proposal will be on week 9. So sa midterm exam, pero dahil nga madaming exam nun, i-adjust natin siya ng week 10. So yung week 10 natin, wala naman tayong meeting doon, pero yun nga, yung kahit wala tayong meeting doon, yun yung submission natin. So ano bang gusto nyo, week 9 or week 10? Kasi ang ayaw ko lang kapag nag-week 10 tayo is, yun nga, baka magreklamo kayo kasi holiday, kasi yung tatapatan niya, pero may isa-submit. Pero yung submission naman ito will be Wednesday. Pero kung gusto nyo pa na magkaroon pa ng time, edi yun, magagamit nyo talaga yung sa holiday. Kasi pwede ko naman kayong pagbigyan hanggang ano ba yun? Hanggang April 1 ba yun? Hanggang 31 pala. Pero Easter Sunday kasi yun, no? Kaya pwede siya hanggang 1, yun. Yun na lang, Pero, yung due date niya, it's 27, no? Para lang wala akong maririnig na may gagawin kayo ng holiday, edi 27 yun, Wednesday. Naintindihan ba? Clear ba tayo doon? Ayun. So, medyo maano din kasi yung paggagawa nito. Kaya you have to make sure na talagang ma-approve siya. Kasi pag hindi siya na-approve, ibig sabihin, gagawa ulit kayo. And then mahirapan kayong humabol sa schedule. Kasi ang schedule ng submission ng design project na is week 15. Yung sa design project na mismo natin will be on week 15. Pasahan na yun ng mismong papel. Kasi 16, 17, mag-start na tayo. 16, start na ng presentation, and 17. Kasi kailangan 2 weeks yung allotted for the presentation kasi 6 groups. So ayaw naman natin na mag-a-adjust tayo ng time after week 18. Kaya, ayun. So sana masunod yun. Kailangan natin strictly masunod yung timeline natin. So week 15 is the submission. You will also be preparing video presentation for the presentation of your design project para doon sa time ng presentation natin ay hindi na siya live gagawin. Kung recorded na, nakapag-practice na kayo, naaral nyo na, and at the same time, alam nyo yung mga isasagot nyo dun sa mga possible questions. Okay? So, focus muna tayo sa proposal. So, focus muna tayo sa proposed design project. So, ito naman is enough time din para sa inyo na makapagawa ng proposal. Okay? So, hindi ko siya isasabay next week kasi meron kasi akong pasasagutan na problem set. And since malapit na yung final exam, so mas maganda na nakapag-practice kayo at masagutan yung mga problem set. So, ayun. So, what is the content of, ito na yung mismong template, bali ganito na din yung mismong ipapasa ninyo. So, you need to include section, yung group number. Yung group number nyo is yung nandun na din sa GC. Proponent, email address, contact number. So, yung iba, may question ba? So, yan, nakalagay dito is yung topic, yung proposed design project. So, introduction, yung laman ng intro. So what is the project about? And what is the motivation? Review any prior work in the subject area. Describe in detail functional requirements, preliminary but quantitative specification, related technology areas, competitive benchmarks, and any related patents. Comment on the scope of effort involved in general terms. So for the objective, sa part naman na to, describe the project goals and intended functions and features. Carefully state how you have narrowed or broadened the scope of the project based on available time and labor resource. Comment on critical design parameters and what challenges might stand in the way of accomplishing your design objective. So be ever alert to professional and societal context of the design objective as it relates to engineering standards. And realistic constraints that includes one or more consideration of economics, environment, sustainability, manufacturing, ethics, health and safety, and social, and political impact. So make sure your objectives are clear. Clear objectives lead to clear plan for generating the task to accomplish the design goals. So as for your design strategy, describe your approach to this project. If your project calls for additional subsystem development, such as special purpose sensors, mechanical components, etc., so you should also discuss your design approach to these subsystems. So you also have to consider design alternatives and ways to evaluate them. A block diagram may be helpful to convey how different components and stages in your design fit together. So next naman natin are the plan of actions. So the plan of actions consists of various tasks needed to implement the design strategy. The task should be linked to the objective and the design strategy components. The task should be divided among the team members for a well-rounded experience for all. So what do we mean by the well-rounded experience? And ito, task should be divided among team members and for a well-rounded experience. So meaning, to be specific, one person doing all the analysis, another simulation, and another implementation, and yet another testing does not lead, okay, to a well-rounded experience. So hindi yun ganon. Yun nga, naka-assign sa isa yung simulation, yung isa sa analysis, yung isa sa computation, yung isa sa paper. So, hindi ganon yung sinasabi na yung task should be divided. So, it means that with a well-rounded experience, all must share these activities, not necessarily in exactly the same proportions. For example, for each task, designate one team member as the lead. So, meaning, for example, kung ano man yung mga processes that you will undergo, for example, dito pa sa proposal ng ref or design project, so pwede kayong mag-assign ng isang team, ng isang lead, doon sa process na yon. Kumbaga, lahat pa din is may input for that process, pero yung isa yung nagmamanage nun. Clear ba tayo doon? So, hindi ibig sabihin na sa kanya naka-assign yung paper, siya na lahat gagawa. Sa kanya na naka-assign yung computation, siya na lahat gagawa. So, hindi. Siya lang yung mag-lead doon sa process na yon, but lahat pa din will add their inputs. So, next naman is for the verification. Outline the test procedures of your project and the resulting table, graphs, and measured values that will assess the project performance. So take note, hindi naman ito result na so ito ay test procedures pa lang. And also, what are the possible tables, graphs, and measured values that you will use in order to assess yung inyong project performance. So they should be correlated with the project specification described in the introduction section. So you also have to describe the test procedure for individual project components and the subsystem, like for model validation, sensor subsystem, and the overall system. So as part of your project, you also have to describe the engineering components, subsystems, or parameters that most affect the performance of the project. You also have to discuss how you will later in the project verify this analysis. So next is for schedule. So para siyang Gantt chart, no? Include a timetable showing which step in the expected sequence of design work will be completed. So generally by week and how the task will be shared among the team members. So, yan, scheduling. So, saan nyo i-base yung sa scheduling? So, nilagay ko na din ito, yung mga contents ng design project. So, meaning yung inyong schedule will be based on the processes na gagawin nyo for this design project. Okay? So, yan. Guided naman kayo. Sasayin na lang din natin. Ito. So, design guidelines and rubrics is, ito na yon. Rubrics is nasa dulo nito. This includes the title page, letter of transmittal, indicates why report has been prepared, gives essential results. So, acknowledgement, table of contents, executive summary, introduction, methodology, design calculations and analysis. Okay? So, yan. This includes the introductory paragraph, design data, design analysis, select your equipment for the proposed design. So, syempre, ito is nakabase na dun sa mga available sa market na component schedule. Kung ano yung mga gagamitan nyo dito. So, for the component, we have project costing example table. So, yun din. Nakalagay na din naman yung mga unit price, yung mga price nung sa mga component schedule available sa market. So, meron din tayo ditong economic analysis and of the proposed design. So, conclusions and recommendations, the bibliography, and yan, appendix, sample calculations. Yan, sa appendices, kasama dapat yung sample calculations, and yan, sample calculations which include the following. Letter of transmittal. The purpose of a letter is to refer to the original instruction or development that have made the report necessary. Yan. Title page and table of contents, executive summary. And then body of the report. Yan. Appendix. Presenting the results, subheading and paragraphs. Yan. Kung ito yung mga format for the paper mismo. Format sa table, graphs, illustrations, nomenclature. Yan. References to the literature, paano siya ilalagay. Yan. For the bibliography, so nakalagay dito, sample calculations, proofreading and checking. We also have your engineering drawing, yung guide sa inyo. So, ito naman are the checklist for the final report. Okay. So, okay. So, these are, again, yung naulit ko kanina na we have checklist for the final report ninyo. So, after nyong matapos yung inyong paper for design project, so you can answer the following questions. Ano ba yung mga kulang nyo? So if all of your answers are yes dito, then kompleto na. Then ready na kayo for presentation. So if not, you need to edit. So again, ito yung 60%. Ano yung mga titingnan? Design problem and boundaries, alternative designs, application of engineering principle, process economics, interpretation of result, clarity of design, dimension and specification, final design. So next, we have the technical content for presentation, logical coherence and development, oral presentation skills, and presentation materials. Take note na. So, do you have any question? Going back naman dito sa ating proposal. So, same pa din, same pa din, although hindi nakalagay dun sa final paper natin, pero may kahiwalay na, ayan, For the part ng proposal, meron na kayong ilalagay na, ayun, yung scheduling, depende doon sa mga task na nandoon sa ating design project. And bibliography, yun yung format na nandoon din. Kung may need na kayong ilagay, kasi dito pa lang sa proposal ninyo, meron na kayong mga related studies na pwedeng ilagay to support kung ano yung gusto nyong design project na ipa-approve. So, statement on the contribution of each team member. So, bukod sa nakalagay ito sa proposal na ipapasa ninyo on week 10, you will also have to include this statement on the contribution of each team member dun sa mismong design project na. So, ano yung nakalagay dito? So, this include a brief paragraph on the contribution of each team member. So, all team members must sign this page. Okay, so same with dun sa design project. So, note, is the problem sufficiently important to justify money, time, and your effort? So, ito naman are the questions that you can ask your group for proposal paper. So, is the project well-defined and realistic? Have you outlined a sound approach, including your ability to perform the task? Okay, so this or both of these templates are already uploaded in our Google Classroom. Okay, so do you have any question? May tanong ba?
Ma'am, paano po ang product po ng aming design project po? Prototype po ba or simulation po through SolidWorks?
Design, hindi na ako mag-request ng, wait lang. Kasi kapag kaya ba siyang i-simulate? Kasi as long as
Parang hindi pa po.
Ayun, meron kasi dito nakalagay na design calculation. So, yung parang diagram, ng components, design.
So, bali po 3D, na lang di po siya, 3D presentation po.
Yes, Utoy.
Thank you po,
Tapos,
ma'am.
meron na schematic diagram. Clear ba tayo doon?
Yes po.
Okay. Any question? Clarification?
Wala na naman po.
Okay. Yes, Janela.
Bali yung groupings po ay wala pa po ata sa group chat. Thank you po.
Wala pa ba? Hindi ko pa na-send. Couldn't send. Bakit? Ba't di ma-send? Ha? Ba't ayaw? Okay, di pala siya nag-send. Wait lang. Buti na ulit nyo. Kasi baka mabago yung groupings, no? Kasi wala tayong wait lang. Isa-isahin ko na lang siya. Magkasama kasi yung picture kanina. So, let's see if... bakit ayaw ma-send? Ba't couldn't send? Kasi sa akin, nagfe-failed siya. May net naman ako. Pa-screenshot na lang. Tapos, send sa GC. Nandiyan nila, pa-screenshot na lang nito. Kasi hindi ako makapag-send. Di ko alam kung bakit. Okay na ba tayo dito? So, next ay ito.
Okay na po.
Okay. May question ba? Question, clarification. So, I think wala. So, bale, this week, pwede naman kayo mag-meeting, di kung kailan na lang kayo available lahat na magkakagroup para ma-discuss nyo. Ayun. Okay. Clear na ba tayo sa submission? Week 10 kasi, wala naman tayong meeting noon. So, yan ay March 27. Para at least kahit wala tayong meeting, mache-check ko na siya.
Ma'am, bali extended nga po siya ng April 1 po. Ano po?
Oo, pero yun nga, kung gusto niyo na siyang ipa-check ng mas maaga, ay di ipasa niyo na siya agad. Kasi etong week na to, kahit na itong week 1 to 5, ayan, inuutay-utay ko na siyang checkan bago tayo week 1 to 5. April 1 to 5 yan, inaano ko na yan. China-check ko na. Kasi madaming section, so ayun, kailangan din na ma-check siya bago para may approved topic na kayo. Okay? Pero ayun, pwede siya hanggang April 1. Any question? Clarification?
Wala pa po, ma'am.
Okay. Nasaan na ito? Ito ba? Okay. So, next natin na discussion. Meron ba tayong hindi na-discuss kahapon? Natapos naman natin yung actual vapor kahapon. Tama ba?
Yes po.
Okay. How about dun sa mga natapos ba natin sagutan yung problem 2? Ano yon? Alin yung hindi natapos? Ano yon? Letter A? Okay, so since nakuha na naman yung mga mga values kahapon, so ito na lang, present ko na lang yung sagot, and then ayan, if meron kayong question, edi i-ask na lang dun sa messenger about this problem. But this is the computation. Discuss lang natin konti. So, nakuha natin yung letter A hanggang doon, dito, no? So, ayan. So, for the value of the length and the diameter, ginamit natin is itong formula na to. For COP, kailangan nating makuha yung work. So, since polytropic process siya, so polytropic yung gagamitin natin to find work. You just have to multiply it with the mass of refrigerant kasi yon, kailangan mag-provide kayo ng unit analysis. Kasi for example, hindi pa natin i-multiply yung mass of refrigerant, then yung unit natin will be in kilojoule per kilogram pa lang. Ay ang hinihingi sa atin is COP pa lang. COP, pero yung ating, kasi, ang ating QA is makukuha natin in kilowatt. So, dapat i-convert natin siya in kilowatt, multiplying the mass of the refrigerant. Okay? So, for the COP naman, ayan, ito yung sagot. For heat rejected, naulit naman natin, diga, na mag-heat balance tayo. Energy balance, tama ba? Okay, so bakit need natin mag-energy balance? Kasi yung computation natin or formula natin for heat rejected is H2, minus H3. So, since hindi natin makukuha yung H2, then therefore, you can use yung ating energy balance. Pero pwede mo naman nakunin yung H2 kasi may work ka na, diga? So since may work ka na, you can use also na makuha mo na yung H2, okay, bago kayo mag-compute. Pero para mas madali, edi ito na lang, yung energy balance. Okay, do you have any question regarding this problem? May tanong ba? Clarification? Yan. Screenshot nyo na lang yung para, ayan, guided kayo. So, stop ko na to. And then we'll proceed with the next topic natin. So, this lecture 4, this is the last topic that we will be discussing na for our for our midterm exam. So, this contains the refrigeration systems and components. Meron din tayo ditong mga calculations for compressor, And then, nandito na din yung part ng condenser and evaporator. So, ito, nandun yung last na gagamitin natin na lecture bago mag-midterm exam. So, kung hindi man natin ito matapos ngayon, so can review na dito. Pero, tatapusin naman natin ito next week. Okay? So, this week then, magbibigay ako ng problem set na i-add natin kasi wala pa tayong problem set for the actual vapor compression cycle. So, yun. And then, meron din itong corresponding na computation. Ito naman yung para naman sa next week. So, since exam week na yung week 9, so dapat masagutan nyo din siya. So, i-required ko na matapos yung lahat ng problem set bago mag-midterm exam. Para yun. It serves its purpose, na makakapag-review or maging review siya for midterm exam. Okay, so let us start. So compressor use in refrigeration system. So we all know naman what is the main function of compressor in a refrigeration system. Okay, so we will in this lecture we will discuss different types of compressor. Kasi hindi naman laging reciprocating or hindi ayun. So dapat alam pa din natin yung type ng compressor para alam natin ano yung calculation natin for work input natin in the refrigeration system. So nagkakaroon lang naman tayo ng work input sa compressor. Kasi yun yung magpapagana sa refrigerating system natin. Okay? So compressor is one of the most important component of the vapor compression system. Although lahat naman talaga ng component is important, So others like condenser, evaporators, and expansion devices has its own peculiar function that makes the system controllable. So since the compressor is the prime mover of refrigerant circulating the system, it is commonly known as the heart of vapor compression system. So we have four most common type of compressor for use in refrigeration system. So these are the reciprocating compressor, screw compressor, we have the centrifugal compressor, and the vane type compressor. So let us start with the reciprocating compressor. Can you please read the slide? Saijal, Nicole. Slide, yung number 1.
Reciprocating compressor. The reciprocating compressor consists of a piston moving back and forth in the cylinder with suction and discharge valves so arranged to allow pumping to take place. The workhorse of refrigeration industry is the reciprocating compressor, built in sizes ranging from fractional kilowatts to hundreds of kilowatts of refrigeration capacity. Modern compressors are single-acting and may be single-cylinder or multi-cylinder. In multi-cylinder compressor, the cylinder are in V-type, double V-type, radial, or inline arrangement. Reciprocating compressors dominates from a very small refrigerating capacities to about 300 kilowatts. The screw compressors are rotary compressors that use rotating elements like a pair of screw inside stationary cylinders. This pair of screw provide positive displacements of gases on the discharge port of the compressor. Screw and small centrifugal compressor which battles for the market in the range of 300 to 500 kilowatt of refrigeration. Centrifugal compressors are compressors whose rotating elements operates to compress gases by virtue of centrifugal force. The centrifugal compressor is the choice for large capacity units, particularly for water chilling plants used for large air conditioning installation. Centrifugal compressors are most widely used for units having refrigerating capacities of 500 kilowatt and above.
Okay. So, thank you, Neng. So, those are the first three types. Ano? So, we have the reciprocating compressor, we have the screw, and the centrifugal compressor. So, as you can see, it has its refrigerating capacities which you can base kung ano yung pipiliin ninyo na type of compressor. So, ayun, nabanggit ko kanina, meron namang mga, yung mga available sa market, meron na specification, and schedule for each of the type. So, kahit hindi yung compressor, kahit ibang component pa na kailangan natin for refrigeration system. So, ang kailangan natin are the actual equipment available in the market. So, lahat yun ay merong corresponding na amount, kung ano yung process niya. So, ma-compute talaga natin kung magkano yung magiging kabuuan ng magiging design niya. So, for the last part naman is the hermetically sealed compressor. Can you please read this, Zerdan? Thank you, Nen.
Hermetically sealed compressors are compressors whose motor and compressors are often closed in the same housing or common housing to avoid leakage at the seal. Improves technique for insulating the motor electrically have allows motor to operate even though they are in contact with the refrigerant. In many designs, the cold suction gas is drawn across the motor to keep the motor cool. Almost all small motor compressors combinations used in refrigerators, freezers, and residential air conditioners are of the hermetic type. The only connection to the compressor housing are the suction and discharge fittings and electric terminals.
Continue, Otoy, hanggang eto. Hanggang bago mag-compressor perform.
Okay po. Moisture in the system can be damaging the motor. Therefore, dehydration of hermetic units before charging refrigerants is essential. Condensing units are components of refrigeration system specifically arranged to combine with compressors in most split type air conditioner refrigeration system. This unit is usually termed as outdoor unit of refrigeration system. The indoor unit consists of expansion valve and evaporators are located inside the room of a split type air conditioner.
Okay, so next naman natin is the compressor performance. So in dealing with compressor's performance, refrigerating capacity and compressor power requirements are the most important performance characteristics of evaluating compressor. So take note, yung refrigerating capacity and the compressor power requirement. So these two characteristics of the compressor operating at constant speed are controlled largely by the suction and discharge pressures. An analysis will be made first of an ideal reciprocating compressor because it gives a clearer understanding of the effects of these two pressures. So trends established from a study of the ideal compressor hold true for the actual compressor. So although adjustment may be made in the numerical quantities. So this adjustment will be examined in the discussion of the actual compressor. So the performance of reciprocating compressor are being predicted by its volumetric efficiency. So take note, this is for reciprocating compressor. So the two types of volumetric efficiencies include actual volumetric efficiency And the other one is the clearance volumetric efficiency. For the actual volumetric efficiency, ito na yung ginagamit natin. So this is the ratio of the actual volume flow rate entering the compressor and the volume swept through by the piston in their suction stroke per unit time. So volumetric efficiency natin is equivalent to VA over VD, where VA is the volume flow rate entering our compressor. So using our state points na normally natin ginagamit, so this is V1 over the volume or the displacement rate of compressor. So this is V1 over VD. So the other one is clearance volumetric efficiency. So minsan ina-equate or nagiging equal na tong dalawang to. Pero discuss natin in what case. Kasi yun na yung ginagamit natin dun sa formula natin sa pag-solve. In-equate na natin to. Depends upon the expansion gas tract in the clearance volume. So what are the formulas for the clearance volumetric efficiency? So this includes the volumetric efficiency or clearance volumetric efficiency is equivalent to 100 minus M multiplied by the quantity V1 over Vc minus 1. So this is for isentropic expansion assumed between Vc. So take note that our V1 over Vc is equivalent to V suction over volume discharge. So take note that this is for isentropic expansion. So meaning for isentropic process ng compression sa compressor natin. So in this case, again, yung ating suction is V1, discharge natin is V2. So V suction is the specific volume of gas entering the compressor, and then V sub dis is the specific volume of vapor after isentropic compression to compressor discharge. So we also have here clearance volumetric efficiency, which is equal to 100 minus M multiplied by V suction over V discharge minus 1. So ito na yung mga equation na na-discuss natin kahapon. So clearance volumetric efficiency also is equal to 1 plus C minus C times the V1 over V2. So in terms of pressure naman, discharge over suction. So this is P2 over P1 raised to 1 minus N. So again, for isentropic process, we can use 1 over K naman doon. Okay? So what do we mean by that M? So M is the percent clearance volume. C is clearance volume. So ibig sabihin, if you percent clearance mo lang yung clearance volume para makuha mo yung M. No. So for C naman, so that is clearance volume in decimal point na naman yun, or in decimal number. PD is discharge pressure, suction pressure PS. So in our case, yung discharge pressure natin, which is P sub D, is equal to P sub 2. Suction pressure natin, P sub S, is equal to P sub 1. And N is the compression index, syempre for polytropic process. So yun naulit natin kanina, that our actual and clearance volumetric efficiency is ine-equate na natin in what case? So, yung ating volumetric efficiency or the actual volumetric efficiency is equivalent to the clearance volumetric efficiency multiplied by efficiency sub S. So, this one is equivalent to PC over T, C multiplied by TS over PS. So, what is this one? So, PC and TC are pressure and temperature at the cylinder. And PS and TS are pressure and temperature at suction of the compressor. So, minsan, kapag walang binigay na ganito, yung N sub S natin is equal to 100% na. So, that is 1. Kaya, ina-equate na natin yung actual volumetric efficiency doon sa ating clearance volumetric efficiency. Clear ba tayo doon?
Yes po.
Okay. So, next are this thermodynamics work of compression. So, yun nga, minsan, pag hindi na siya isentropic process, so hindi na natin makukuha yung value ng enthalpy at state point 2. So, hindi natin magagamit yung heat balance. So, what we should do kapag polytropic process na siya, we can use this formula. But this can also be used sa isentropic work of compression kapag binigay yung value ng K. But ayun, this can also be your basis kung tama yung nakuha mong enthalpy, kapag isentropic, then you can use this if you know the value of K or given sa problem. So we have isothermal compression. Syempre, if constant temperature, compression of gases. We have isentropic work of compression if we have constant entropy compression of gases. So for polytropic compression naman, so it's a compression whereby the compression index N is specified at a given compression of gases or line of compression on the PV or pH diagram between isothermal and isentropic line of compression. So we have here thermodynamic equation of each line of compression. So for our isothermal compression, we have this, P1 V1 ln ng P2 over P1. For isentropic work of compression naman, yun yung ginamit na natin sa calculation natin. K over K minus 1, P1 V1 multiplied by the quantity P2 over P1 raised to K minus 1 over K minus 1. For polytropic naman, you just have to use N, yan. Parang pwede namang isa na lang sa uluhin mo, and then K for isentropic compression index, and N for polytropic compression index. Okay? Do you have any question dito? Question, clarification, or can we continue? Ayun.
Continue po, ma'am.
Okay, next na natin is the performance of ideal compressor. So in the ideal compressor, the compression of gas and the re-expansion of gas trapped in the clearance volume are both isentropic. So the only factor that influences the volumetric efficiency of the ideal compressor is the re-expansion of gas trapped in the cylinder head of the ideal compressor. So to show the effect of temperature on clearance volumetric efficiency, we are going to apply our data with the performance of ideal refrigerant 22 compressor. So displacement rate of 50 liter per second at 4.5% clearance and 35% condensing temperature. So in order to practice our calculation capabilities, let us fill up the accompanying table and plot the curve for volumetric efficiency and mass flow rate. So yon, ito kasi may sagot na, pero try nyo din kung tama yung magiging sagot nyo. Okay, so ano bang kailangan natin dito? Ang walang value is the clearance volumetric efficiency at itong mass flow rate. Ang mga given sa atin are the evaporating temperature, the suction pressure, and the discharge pressure as well as the specific volume. So try to fill up itong clearance volumetric efficiency at itong ating mass flow rate. Okay, so with the value of K, ito yung mga pwede nyong gamitan. So ito yung mga na-discuss natin kanina. So take note, you can use the value of K as 1.17 and C is 4.5%, which is given naman dito. So ang hindi lang given dyan ay itong K, natin. So use K is equal to 1.17 for R22. Okay, so pa-confirm naman ako kung merong mali na data dito. Pero at least alam nyo paano siya isosolve. If may binigay na ganitong klase, table. Okay? Patry naman ako. So, I'll give you 5 minutes.
Yes po.
Okay, did you get the same values?
Yes po, ma'am. Same po.
Okay, so makikita nyo naman to dun sa ating uploaded na lecture. Ano? So let us continue. So if you will be plotting those values dito sa table na to, then we can get the graph, for the curve of, so graph of clearance, volumetric efficiency, and mass flow rate in kilogram per second. So ito yung magiging graph niya. Okay. So next we have here the power requirement of the ideal compressor. So the compression process for ideal compressor is isentropic in nature. Thus, the power requirement for ideal compressor is the product of mass in kilogram per second and the enthalpy difference between suction and discharge of the compressor. So this is what we do din naman in order for us to get the work, or power requirement in the compressor. So that is mass of refrigerant in kilogram per second multiplied by H2 minus H1. So discharge natin is 2, suction natin is at state point 1. Okay, so dagdangan muna natin to and then we'll proceed with this. No? So kindly read this slide. Wait lang. Kindly read this, Vince Leonardo Rabino. Yung lang, isang paragraph.
Yung capacity po. Okay po. Capacity control on compressor. If a refrigeration system is operating in a steady state mode and the refrigeration load decreases, the inherent response of the system is to reduce the evaporating temperature and pressure. This change in the evaporator condition results in reduced compressor capacity, which ultimately matches the reduced refrigeration load. The reduction in evaporator temperature may be undesirable for several reasons. In air conditioning, the coil may collect frost and block the airflow, further reducing the evaporator pressure. Stored fresh food and many other products may be damaged by low temperatures. If the evaporator chills the liquid may freeze and burst a tube in the evaporator.
Okay, so here are the methods used in order to reduce the compressor capacity. Okay, kindly read this, Rose Diane.
Methods used to reduce the compressor capacity. In cycling, the compressor stops and starts as needed. The methods of work well in small systems. Back pressure regulation throttles the suction gas between the evaporator and the compressor to keep the evaporator pressure constant. This method gives good control of evaporator temperature but inefficient. By passing the discharge gas back to the suction line usually affords precise capacity reduction, but the method is inefficient and the compressor runs hot. A prepared bypass circuit delivers the discharge gas that is bypassed back to the entrance of the evaporator. Another method is cylinder unloading on a multi-cylinder compressor by automatically holding the suction valve open or diverting the discharge gas from cylinder back to the suction line before compression. In reciprocating compressor of two heads, two horizontal lines carrying high-pressure oil from the oil pump at the right end of the compressor to hold the suction valves open when the unloaders are activated. The loss in efficiency with cylinder unloading is moderate. A step control may be provided with unloads more and more cylinders as the suction pressure drops.
Okay, so this idea, so yung mga idea na to, you can use this in your design project. Okay? You should also in order to reduce compressor capacity. So next naman natin is the rotary compressor. Kindly read the slide. Rain. Rain S3.
Rotary compressor used in a refrigeration system include screw compressor and vane type compressor. A screw compressor has two rotating elements, the male rotor, which drive the female rotor inside the stationary cylinder. The refrigerant vapor enters one end of the compressor at the top and leaves the other end at the bottom. At the suction position of the compressor, the void is created into which the inlet vapor flows. Just before the point where the interlobe space leave the inlet port, the entire length of the cavity or gully is filled up with gas. As the rotation continues, the trapped gas is moved circumferentially around the housing of the compressor. Further rotation results in meshing of the male lobe with the female. Makikibaba po. Thank you po. With the female gully around the housing of the compressor, further rotation resulting in mesh of the male lobe with the female gully, decreasing the volume in the cavity and compressing the gas. At a certain point into the compression process, the discharge port is uncovered and the compressed gas is discharged by further meshing of lobe and the gully. The screw compressor was developed in 1930s and first became popular in refrigeration service in Europe in the 1950s and 1960s. Many screw compressors are equipped with sliding valve for capacity control. It is in the housing of the compressor and can be moved axially. As the valve is opened, it delays the position at which compression begins. The capacity can be modulated down to about 10% of full capacity, although there is loss in efficiency in the capacity reduction. The best screw compressor efficiency is in the range from 70 to 80%. It dependent on pressure ratio and the built-in volume ratio of the compressor.
Okay. So next. Kindly read this. Ralph Lindon.
Vane type compressor. The two basic types of vane compressor are the roller single vane type and the multi-vane type rotary compressor. The components of a single vane type are shown in figure 4.3 below. It has stationary casing cylinder, a rotor or roller, which is a rotating element. A spring-loaded vane is always in touch with the rotor, the intake port, and the discharge port.
Okay, next, Micaela Tumambing.
The components of multi-vane compressor compared to single vane are stationary cylinder, rotating cylinder, intake port, discharge port, and two or more number of vanes. See figure 4-4 for two-vane compressor physical components.
Okay, so about this centrifugal compressor, Mark Neil Undang.
Centrifugal compressor. The first commercial centrifugal compressor used in refrigeration service was promoted by Willis Carrier in 1920. The largest application is in chilling water to about 6 degrees Celsius to 8 degrees Celsius in an air conditioning system. The centrifugal compressor are similar in construction to centrifugal pumps in that the incoming fluid enters the eye of the spinning impeller and is thrown by the centrifugal force to the periphery of the impeller. Thus, the blades of the impeller impart a high velocity to the gas and also build up the pressure. From the impeller, the gas flows either in diffuser blades or into a volute, where some of the kinetic energy is converted into pressure. The centrifugal compressor may be manufactured with only one wheel if the pressure ratio is low, although the machines are generally multi-stage. Centrifugal compressors operate with adiabatic compression efficiencies of 70 to 80%. So, see the figure for physical configuration of the centrifugal compressor.
So again, yan yung mga parts ng ating centrifugal compressor. We have the volute casing, we have the discharge port, the impeller vane, and intake port. Na-discuss nyo naman din tong different types of compressor. Ano? Tama ba? Sa fluid mock. Can anyone confirm? Yan. So same goes with the different equations used for vane. So next week we will be discussing the vane type compressor. But in this class, we will be discussing muna equation for centrifugal compressor. So i-add ko na lang siya dito sa lecture na to. So for the equation for centrifugal compressor, so the equation for centrifugal compressor performance is derived from the tip speed to develop pressure. So this figure 4-6 shows the torque. The impeller ideally imparts to gas. So we have here the torque is equivalent to mass of gas being compressed. So in our case, so that is the mass of the refrigerant. Yan, mass of gas being compressed. Kung ito yung gagamitin natin na compressor, so that is the mass of refrigerant, multiplied by the quantity V2, R2, and then V1, R1. So ano yung mga values na yon? So that is the velocity, nakalagay naman dyan, and then the radius 2, tapos ito naman yung R1. Okay, so for torque naman, for the torque, that is equivalent to, if the velocity at state point 1 is 0, then torque can be obtained using velocity 2 and radius 2. Okay, so for ideal power, ang ideal power natin is equivalent to, yan, angular velocity multiplied by the torque. Where in torque natin, if velocity is equal to 0, if V1 is equal to 0, so that is mg V2t R2. So what is V2t? Tip speed at radius R2 in meter per second. So also, it can also be obtained through change in enthalpy dun sa ating pH diagram or dun sa mga na-obtain natin value multiplied by the mass of refrigerant. So yung 1,000 na multiplier, depende yan dun sa unit niya. Kung anong unit nito. But in this case, yan, for the change in enthalpy natin, change in enthalpy of gas between suction port and discharge port of the compressor. So P, yan. So yung ideal power natin is equal to PI din, nitong equation na to, so we can obtain this one. So for the mass of refrigerant or mass of gas multiplied by 100, delta H, is equal to mass of refrigerant times the angular velocity times R2 times V2T. That gives us V2T is equal to the angular velocity R2. So ito naman is yung mga formula natin for centrifugal compressor. So yung V2T natin can be obtained or equal to the angular velocity multiplied by R2. So from that, we can substitute it to the value na nandito. So in this case, ayan, V2 or V squared 2T is equal to the square root of 1,000 times delta H. So kung mapapansin natin dito, ito, cancel mg. Okay? So since ito, V2T is equal to WR2, so therefore, ito, equal din siya sa V2T. Naintindihan ba? Equal to, no? Okay, clear ba itong formula na to? So where T is torque developed on the impeller, compression, again, yung mass of gas, and in our case, pwede siyang mass of refrigerant kung ano yung pumapasok sa compressor. So V2T is tip speed, angular speed of the impeller naman yung omega. Omega nga ba ito? I'm not sure, pero ito yung symbol niya. P sub I is the ideal power at isentropic compression of gas. Delta H is the change in compressor. Okay, so meron ditong sample problem. Discuss na natin to next week din. Pero itry na din. Okay? So, meron ba kayong tanong? Do you have any question? Clarification?
Wala pa naman po.
Okay, so goodbye class, and see you next week for the additional discussion nito. Ano yung mga naiwan natin, are the computations for this compressor. So we'll be discussing it next week. It also includes yung mga sample problem and problems na under ng lecture na to. And then for the problem set, ngayong week may dadagdag ako. I'll be giving it tomorrow, Monday, para masimulan nyo na siya. Kasi yun yung computation natin for the actual vapor compression cycle. Okay? So if you don't have any question, goodbye class, and see you